Hello everyone, I am Karthik Gurjar. Today I am presenting part 1 of our internal test analysis which covers question 1 through 20. This section focuses on foundational concepts in data science, including big data characteristics, probability and statistical modeling. This presentation is submitted to Dr. Shaligram Prajapati. Moving on to our first question. We define big data using the classic three V's: volume, velocity, and variety. Question 2. We looked at conditional probability. The formula for PA by B is the joint probability of P of A and B divided by the probability of PA and B by P of B. This measures the likelihood of event A happening given that event B is already occurred. Next question. We identify the mode as the most frequent element in a dataset. Question 4. In feature engineering, we discussed in binning. This technique transforms continuous numeric data into categorical bins, which helps in handling nonlinear relationships and noise. Next question. We identified the Poisson distribution as the correct model for counting the number of events in a fixed interval of time or space. Question 6. We distinguish inference for prediction. Inference is about understanding why and how variables relate, the relationship between x and y, rather than just predicting the outcome. Next question. We discuss the bias variance trade-off. A high bias model oversimplifies while a high variance model captures noise. The goal is a balance. Question 8. We define non-parametric models as those that make no assumptions about the underlying functions form, which gives them flexibility but risk overfitting. Next question. For evaluating classifier, the best possible area under the curve AUC for an ROC curve is 1. This represents a perfect model. Question 10. We clarified the logistic regression despite its name is used for classification tasks with a categorical response. Next question. Similarity and clustering. We identified cosine similarity as a metric for vector. It measures the angle between them, focusing on orientation rather than magnitude. Next question. For clustering, hierarchical clustering produces a specific tree like visualization like a dendrogram, which shows how clusters are merged step by step. Next question. We explained that random forests use a technique called bagging, combined with random feature selection to decorrelate the trees, reducing overall variance. Question 14. In deep learning, dropout is a technique used for regularization by randomly dropping neurons during training. It prevents the network from becoming too dependent on a specific path, thus reducing overfitting. Next question. We highlighted the Apache Spark is distinct because it processes the data in memory using RDDS, making it much faster than disk-based system. Question 16. In Python, dictionaries are collection of key-value pairs, allowing for fast data retrieval based on unique keys. Question 17. In TensorFlow, placeholders are used to feed input data into the computation graph at runtime. Question 18. PCA Principal Component Analysis is a technique used for dimensionality reduction. It projects data onto orthogonal axes to reduce complexity while retaining variance. Next question. Finally, boosting. Boosting is an ensemble technique that focuses on improving weak areas. It builds models sequentially where each new model corrects the errors of the previous one. Next question. In SQL, the group by clause is used for aggregating data. It groups rows that share values so we can perform calculation like sum or count on each group. Thank you. That concludes the review for the first 20 questions.